Hello viewers, welcome back to my channel, and in this video we are going to solve a multivariable tutorial. We're going to solve a question under limits of multivariable functions. If today is your first time joining this channel, don't forget to subscribe and also like the video as well. I have two problems for today's tutorials, and the first one is find the limits as xy approaches 0, 0 of the function, which is a rational function, y squared multiplying 1 minus cos of 2x all over x to the power 4 plus y squared. And the second question is to find the limit as xy approaches 0, 0 of y squared plus open bracket 1 minus cos 2x all squared all over x squared x to the power 4 plus y squared. Watch the video to the end. Don't forget to like the video at the end also and share. Let's tackle the first tutorial. So for the first one, we have to find the limit as y approaches 0. When you talk about limits from single variables where we used to have only one variable, we approach a limit point from either the left side or the right side, which introduces the right limit and the left limit. In multivariables or in multivariable functions, we don't have the left and the right limits because it's a 3D or three-dimensional space function. We can approach that function from several ways, through lines, through curves, or even just a point. So let's see how we go by this. I have my function to be y squared open bracket 1 minus cos 2x all over x to the power 4 plus y squared. And I'm finding the limits as xy approaches 0, 0. So how do I go by this once again? So as I was saying, to test for limits, you know that in single variables, your left limit should be equal to your right limit. But in multivariable, what we say is wherever you approach this function at xy equals 0, 0, you should get the same value. If you approach it through a curve, through a line, it should still give us the same solution for us to say that the limit exists and it indeed exists at that particular point. So how do we test that? Basically, if they give you any function which is a multivariable function to test, we first test for the basic lines s equals 0. We test for y is equal to 0. Then we can test for y is equal to x, which are the basic lines you can test for multivariable functions. Also, we can test for curves such as y is equal to s squared, y is equal to s cubed, and so on. But in any of these cases, you are supposed to get the same solution for our computation. So now let's try. So first of all, we're going to take when s is equal to 0. When s is equal to 0, that is our first scenario. So what does that mean? Wherever I'm going to see x, I'm going to put 0 there. So I'm going to have my function to be y squared open bracket 1 minus cos of 2 multiplying 0 all out of 0 to the power 4 plus y squared. So this will give me, you know that cos 2 multiplying 0 is the same as cos 0, where is 1. Everything here is going to give me 0 all over y squared. And if I'm to find the limits of this resulting solution as xy approaches 0, 0, it's obviously my answer will be what? 0. Let me find for y is equal to 0. For y is equal to 0, I'm going to have 0 squared open brackets 1 minus cos 2x all over x to the power 4 plus 0 squared. This is in the case for y is equal to 0. So what am I going to get in this part? This will be equal to, since this place is 0, my numerator turns 0. So I'm going to have 0 all over x to the power 4. Considering this function, Finding the limit as xy approaches 0, 0 will obviously give me 0 because this function results into what? 0. Any number, 0 over any number is 0. So obviously our function itself will be 0. Now, we've tested for 2 lines. So we can't conclude that the limit is 0 and it indeed exists. But we need to test for one more line. These are the fundamental lines and it doesn't end there. So let's test for another line to see if indeed our limit is 0. So we are going to test for line y is equal to x. This is the line that passes through the origin diagonally. So let's see how we go by this. Wherever I'm seeing y, I'm going to put x there because it's saying line y is equal to x. So I come back to my function. Wherever I see y, I put x there. I'm going to get s squared multiplying 1 minus cos 2x all over x to the power 4 plus my y squared. I'm going to put x there, so I'm going to get s squared. So once I get this, I can still break it down and I'm going to get s squared 1 minus cos 2x all over. I factorize s squared out. I'm going to get s squared plus 1. You know, at this point, I can cancel this s squared here with this because they are multiplying. So this will cancel this, so cancel this as well. I'll be left with 1 minus cos 2x all over s squared plus 1. Now this is my resulting function and I'm to find the limit as s approaches 0. So what do I get? You know that if I'm to put 0 here, I'm going to get 1 minus cos 2 multiplying 0 all over what? 0 squared plus 1. And this will give me 1 minus 1, since cos 2 multiplying 0 is the same as cos 0, all over 1. This will give me 0 over 1. So my limit is going to give me 0. This is enough to conclude that our function y squared multiplying 1 minus cos 2x all over x to the power 4 plus y squared has a limit point of 0 as xy approaches 0, 0. So therefore, limit is equal to 0. So back again, I said you first test for x is equal to 0, y equals 0. Those are the fundamental lines, which is the x-axis and the y-axis. Then you test for y equals x. Make sure in any of these cases you don't get different answers. You are supposed to get the same answer for you to conclude that our function has a limit at that point. And that is for the first equation. We are moving straight to the second function I have. That is the second tutorial question I have. That's number 2. In this one, I'm having limits as xy approaches 0, where I have y squared plus 1 minus cos 2x all squared, and everything here over x to the power 4 plus y squared. So with this function, and from how we solve the first one, we have to test for s is equal to 0, y is equal to 0, y equals x, and so on. But now, first of all, we want to compute this and find the limits, if the limit exists, and if it indeed exists, what will be the limit value. This problem has a different way to approach it. Let's see how we go by that one too. So, in this problem, we are going to test for a line y is equal to m, let's say a curve m squared, mx squared. The reason is, as I said, in multivariable function, if you want to test for limits with wherever you come from to that point should give you the same value. So what we're going to do is, you have to take a line or a curve. So when you find the limit as that line is approaching your function, you should get the same solution. Then you can conclude that the limit exists. So in this scenario, we are going to take a generalized curve. And if I say I'm taking y is equal to ms squared, I can get y is equal to 2s squared when m is 2. I can get y is equal to 3s squared when m is 3. So this general function can test for so many curves. So if I use this general notation to test for my function, I can indeed conclude, though I've chosen one, but this is a generalized function, which is a curve, which m can be half, m can be any number. So if it happens that the solution of this limit depends on m, or if you find m in the solution, then it means that if I change the values of m, I'm going to get different solution for our limit function. Therefore, the limit wouldn't exist then. So let's see. So I'm taking the generalized form y is equal to mx squared. So taking this y equals mx squared, wherever I see y, I'm going to put ms squared there. So I'm going to have open bracket ms squared all squared plus 1 minus cos 2x all squared, and everything over x to the power 4 plus, I still have ms squared here all squared. As I'm having this, I'm going to simplify. This part is going to give me m squared x to the power 4 plus, if you have 1 minus cos 2x, this is the same as 2 sine squared x and everything squared all over x to the power 4 plus m squared x to the power 4. One will ask, why is 1 minus cos 2x equal to this? Let me shortly show you how we do that. You know that cos 2x is simply equal to sine cos squared x minus sine squared x. So I'm going to make this the subject from one identity as 1 minus sine squared x minus another sine squared x should be equal to cos 2x. So from here I'm going to get cos 2x to be equal to 1 minus 2 sine squared x. Then I'm going to make 2 sine squared x the subject, which will give me 2 sine squared x is equal to 1 minus cos 2x. Then I can make the substitution here. So now you know why 1 minus cos 2x is the same as sine 2 sine squared x. So let's proceed. So once I get this, I'm going to further simplify to get m squared x to the power 4 plus 4 sine to the power 4 x all over x to the power 4 plus m squared x to the power 4. So once I have this, I'm finding the limits as s approaches 0, 0. That is xy, sorry. What do I do at this point? At this point, I'm going to divide through by x to the power 4, since I can find it at here and here. So when I factorize it out, I'm going to get m squared plus 4 sine to the power 4x all over x to the power 4, and this all over 1 plus m squared. I have divided through by x to the power 4, and this is what I'm getting. So now I'm going to find the limit as x approaches 0, 0 of this. So now, how do I get this? The limit is going to depend on this part of our function because this is a constant, this is a constant, this is a constant. So this is simply equal to m squared plus limits as x approaches 0 of 4 sine to the power 4x over x to the power 4, everything over 1 plus m squared. And when I have this, computing this alone, that is limit as s approaches 0 of 4 sine to the power 4x over x to the power 4. From L'Hopital's theorem and from trig identities, we know that if you have 4 sine to the power 4 here and I have x to the power 4 here, limit as this approaches 0 is simply going to give me 4, because this whole thing will compute to 1. When I get 4 like this, my answer becomes m squared plus 4 over 1 plus m squared. So this happens to be the solution for my limit. So if I have chosen m to be 2, I would have got 2 here. If I had chosen m to be 3, so let's say if I chose m to be 2, choosing y is equal to 2s squared, meaning wherever I see m, I'm going to put 2 there. So this will be 2 squared plus 4 over 1 plus 2 squared. And that is going to give me 8 over 5. If I had chosen y is equal to 3s squared, which are different curves, I should get the same answer. But let's see. When I put 3 inside, I'm going to get 9 plus 4 over 1 plus 9, giving me 13 over 10. Since they're getting different solution, we conclude that the limit doesn't occur at point x, y, 0, 0. So therefore, the limit of the function that was given in the question does not exist. It doesn't exist. So this is another way of showing limits in multivariable calculus. If you have any question, kindly drop it in the comment section. Don't forget to like, subscribe, and also share.